Well, welcome. Thank you. Thank everybody for being here. We really appreciate it. We're doing a talk on DoxyPress. And this is a fairly new release that we have. We're going to be talking about why documentation is important. We're also going to be talking about the limitations of Doxygen. We're going to also cover why we did DoxyPress, what it is, and where it's going. A little bit later in the talk, we're going to be talking about the internals of what we did moving from Doxygen to DoxyPress, because we were basically taking an application that was done in C++ 98 and we moved it to 11. So we're going to talk about some of the samples and examples of what happened internally and why we had to do this. We're also going to talk about the future of where we're going with DoxyPress. Please feel free to ask questions as we go along. We like to keep this informal. So the question is, why do we need documentation? The obvious reason is to document your API or your user interface that you have for your customers. That one's obvious. The question is, why else do you need documentation?
And the not so obvious reason is your future self, because it's not useful to spend those brain cells having to re-understand your source code again and again. There's also a lot of things that should be documented that aren't always in projects. How to set up your build environment, the usual class and method documentation that we're mostly familiar with. But often what's overlooked is the overall system design, perhaps a change log to let you know what's happened since the last time you looked at the product. Particularly documenting error conditions of even trivial methods is very important and often overlooked. And then examples of how to use the code or the product or the utilities or whatever it is that you're documenting.
Question is, when should you start documenting? First day of the project. That's when documentation starts. We're actually the founders of CppCon and that library. We started the documentation, the overview documentation, day one. Ansel thought it was a little silly, but it wasn't. We actually started using our own internal documentation to do some of the building. And when we started using it, we found problems in the documentation. First 5 or 6 times we were building the samples and getting things going, we couldn't follow our own documentation. So we would change it every time. So we made sure that when we needed to set up a new build environment, we followed our own instructions. So by the time we got further in the project, it actually worked and reflected what was in the project.
Now, if you don't have the good fortune to have started on day one of your project, at least start yesterday. That's far preferable. If you didn't do it yesterday, then today is a good day too. Tomorrow, almost as good.
So we wanted to talk about Doxygen. Doxygen was developed in about the mid-90s. It is open source. It is a GPL. It was written in C++. However, the containers and the classes inside, they are Qt 1.9, sort of. What they did is 1.9 had some types of containers and classes. We're going to talk a little about what they looked like. The problem is, as it became obsolete, and this was back in the Trolltech days, the maintainer of Doxygen, what he did is he exported the classes he needed, and he brought those in so he could use them by hand. So it was no longer part of the library. They're not exactly maintained very well, though. He also had some non-standard functionality, especially in things like translations. For documentation, you're going to be in a lot of languages, and using a non-standard translation system is very problematic.
There were a lot of problems with this old class library that was used in Doxygen. One of them is that all of the containers were pointer containers, not value-based containers. And this goes hand in hand with a technique that was used at that time called auto-delete memory management, which is extremely error-prone. And the issue is that if you had an object that was stored in multiple containers, you had to pick one container to be the owner of that object, and it would be in charge of deleting that object when it was removed from the container. This created all kinds of interesting use after free and memory management bugs that we discovered and resolved.
And the code, Doxygen is riddled with raw pointers. It's mostly what it uses, a lot of memory leaks, a lot of problems. a lot of things that were raw pointers that didn't need to be pointers at all. As you can see, we have a list of what made the code a little bit hard to read. There are actually sections of the code where you read it, and the variable names are I, li, lti, things like this. Ansel and I do tandem programming. I'm actually the one sitting typing at the keyboard. He's got his computer running some tests. He always keeps the C++ standard open so we can verify everything. And there were times that we were just squinting, trying to figure out, is this an I, is it an L? It really didn't make sense. It was hard to read code. We did clean that up, because these are not variable names I want to see, and we didn't even show all of them. So what's wrong with Doxygen?
Well, there are a lot of issues centered around its HTML generation. It supports other formats as well, but HTML is by and large what most people want as an output format, us included. And if you ever want a laugh, take the current version of Doxygen, open a div at the beginning of a page, and close that div at the bottom of the page, and check what output you get. It is unbelievable. There's also problems with if you're designing a table in your documentation. If you use blank lines within that table, it will completely mangle the remainder of the table. This can make your documentation extremely difficult to read because you can't break apart what can potentially be a very long table into readable sections. There are so many other issues with the HTML output. It's not HTML5, it's not even HTML4. One of the most challenging and most difficult ones was a problem with the system that's called auto brief, where it extracts the first sentence of the documentation of some entity to use as the brief documentation to be displayed elsewhere. In many cases, the effect of the auto brief system is simply to make all of your documentation disappear for a given method or function or whatever it is you're documenting. Another large problem is the fact that it is unable to parse many macros, including some of the things that we needed to document the CppCon library.
This is where we did run into problems. When we were doing the CppCon overview, it sort of worked. And again, I like blank lines in my tables. This didn't work. But the problem was actually doing the API. Doxygen failed. It could not parse anything. It couldn't parse modern C++. It couldn't parse our macros. We felt very stuck. We felt lost and confused because here's a product that's very well known and it is being maintained, but it didn't work. We didn't quite know where to turn. We actually did contact the maintainer. We exchanged some emails. He actually wasn't all that receptive to changing the things we wanted changed. We did consider, should we make these changes and upstream them? Then we started looking at the internals, and we started looking at what Doxygen was doing inside. We realized that to change Doxygen and to make it actually work, there was going to be no way to upstream it. So we didn't have a lot of choices. We found the code to be absolutely unmaintainable. There were too many existing issues and problems on current bug reports, and we had to make a very hard choice. We did this the end of last year. So we forked Doxygen and created DoxyPress. This is what we felt was the best thing we could do. We needed a program that worked, that did documentation. We've been working on this for about 8 months. We have released it. It is out there. All of our CppCon documentation has been actually generated with DoxyPress. We did start with version 1.88. We have backported changes through 1.8.10. We'll continue to backport any changes that seem relevant from Doxygen into DoxyPress. If you're familiar with Doxygen, there is a wizard to help you generate the project file. That was called DoxyWizard. We did have to do a complete rewrite on that, and that is our DoxyPressApp. Part of the reason why we had to do a rewrite is because how the project file is generated. We'll talk about that in a little bit. But DoxyPress and DoxyPressApp both link with our CppCon library. So that means we were able to get rid of all the cute 1.9 containers and classes.
So let's look at some actual code from Doxygen. One of the issues with the class library, pardon me,
it has to do with the type of code that you're seeing right up here. As you can see, the @0 and the @1, there's no checking.
the issue is that instead of returning an error, as one would expect, or an exception, if you index off the end of a container or a string, these old class libraries simply return null, or a null pointer if it was a container. This made the code extremely challenging to port to any current container library because there was no checking the string was long enough. So what we've had to do with the code is to modify it. We're using the QString class from CopperSpice. It's very similar to stdstring. And one of the major changes has been that we've had to check the length of the string before indexing into it, as one would in normal modern code. Alternatively, in many cases, what we've done is change code like this into what you see on the bottom of the screen, where we're using starts with instead of individual character comparisons. And this is a implementation of the general idea that your code should actually say what you mean. It's much easier to read a line that says, if result starts with, than checking for two completely distinct characters.
So again, we had switched on the old classes, the Qt 1.9, with everything being pointer-based and not value-based. This is also why we had to test and do the error checking, which made debugging very difficult in the beginning because he didn't have to check because he did rely on the null pointer and we weren't with correct classes and containers. Now, one of the things you can see here is this for all three. This is a macro. It exists today in Doxygen. He doesn't use variadic templates. He doesn't use templates. So what he did is he set up a macro. And in this one, it is forwarding 3 parameters. We just put the macro code here so you can see what it does. But what's actually happening is there isn't just one for all 3. There are actually, as you can see, 9 different forms of for all 3, depending on the data type. It's a smaller font. We wanted to show all of it. We didn't want to show for every format, but there are ones for passing 6 parameters, 5, 4, 2, and if he's passing 1 parameter that needs to be forwarded, there are actually 12 different forms. This is not current day code. It is macro code. We're not against macros, but this should be a variadic template. So we were able to remove all of this code. It's roughly about 200 lines, and we took it down to 9 lines. It's a variadic template. Now the advantage we have is as a variadic template, we don't care if you're passing 3 parameters. We don't care what the data types are. This is code that just works as is. So we don't ever have to go back now in DoxyPress and say, oh my gosh, we forgot some different combination of parameters.
So what we've done with DoxyPress is, as I mentioned, removed all the Qt 1.9 classes and containers. There was another fundamental issue with the old data structures, which is that their string class had an automatic conversion to a character pointer, which made the code, again, extremely difficult to read because you had to know how a parameter was being received to know about ownership and memory management and all sorts of interesting issues there. The containers being pointer-based instead of value-based was a huge, huge downfall in this code. We have completely reformatted the code so that it conforms to a standard. I know there are many arguments about formatting standards, but I do believe that every project should at least pick one.
We used A style for formatting, and we tried to, I think we're very close to KNR's standard formatting. We do believe that all of, every if should have a curly. That was our choice so that we don't miss one. His particular code, they're missing curlies, they're missing line breaks. It's just sort of all put together, and it just hasn't really been updated. Again, it makes it hard to read and hard to maintain.
We have updated the source code to use a lot of the wonderful features that C++11 provides for writing good, maintainable, usable code. We've used shared pointers extensively instead of the myriad places that raw pointers were used. We've resolved an unknowable number of memory leaks in the process.
And I mentioned before that we had to completely rewrite his Doxy wizard doing the DoxyPressApp. The reason why is because he had a flat file as his project. It does have comments in it, but that flat file had to be processed with Lex. So it was Lex code. So anytime another feature is added to the project file, he has to change the Lex code in his Doxy wizard so that it can understand another parameter. We've actually changed that to a JSON format. Currently, our JSON format is in a linear format. So if you look at our product right now, that's the way it stands. Over the past couple days, it's been gently suggested that we modify our JSON format so it uses more of a tree format and more of a standard JSON format. We are going to do that. We just wanted to make it a little more compatible out of the gate. The other thing is, if you have a project that has been done in Doxygen, we can automatically import and convert your Doxygen flat file format to a DoxyPress format. It's extremely simple. And any parameters we add will be very trivial to add to the JSON format. Also, in our DoxyPressApp, the way the help is done, if you're familiar with his wizard, we've enhanced the help so it's done in a much more clean format. So it's done as a mouse overview that works a lot better. And we've also enhanced the help text that shows up so that you can understand what the fields are. We've also modified a little bit of the layout. Yes?
I preferred the documentation within the config file when trying to adapt it without using the wizard. Is that still available with the JSON?
Yes, the question is, do you have to use the wizard? Do you have to use our app to generate the project file? No, you do not. There is text within the JSON file, so if you want to do it by hand, you absolutely can. Again, we're going to modify the layout of the JSON file to make it a little cleaner and a little more obvious how it works, but you can directly modify the JSON file. By going to a JSON format, we also were able to remove that Lex parser in DoxyPress. All of the parsing currently for code is done with Lex parsing, which we're modifying, but that particular flat file parsing has been removed. Any other questions on that? Okay.
So, along our journey, we have fixed the HTML output, we've removed the extraneous divs, we've fixed the table handling so that you can use whitespace and blank lines correctly. We've also added a new parser for makefile syntax, since that was one of the useful things for our project. So DoxyPress now understands makefiles.
The sort ID that you're seeing there is something that we added. I'm a bit picky on the layout, especially for our Copper Spice overview. I wanted the overview to be in a very specific format. Just one of my quirks, but it's what I enjoy. There was no way with Doxygen to say, I want these pages in this exact order. So we have actually generated a /sort ID. So now you can specifically, underneath where you would specify a page, you can say the sort ID, and you can say, this is the order I want, so it will come out that way in the tree view.
We've also fixed a place where the original developers of Doxygen simply misread the HTML standard, and they never realized that you can have multiple DD tags for one definition in a definition list. We ran into this and discovered that it simply discarded what it considered to be extraneous information, which was somewhat problematic. That's been resolved. We've also markedly improved the way that images are handled in your documentation. The old code required every image to start and end a new paragraph, which meant that you could not flow text around an image in a smooth fashion. And with the new code, you have the option of embedding your image in a paragraph by itself, of course. But in general, that's not what you want, and you certainly don't want to be restricted to only that functionality.
We have a link up here. We actually have a timeline of things we have added. We're only showing a few of what we consider to be like the major changes, but we are keeping this timeline up to date that is showing, it is basically a change log, but it's really showing what we've added and what we've changed currently. So we do keep that current. Okay, yes.
So, having said a lot of things about that, it's time to look more generally at some of the issues that we faced in converting an old code base to a modern code base in ways that might be more applicable to other projects as well. And so we discovered some interesting things along the way, and I'd like to give you some general concepts of the issues that we encountered. One of them was that there were many classes in Doxygen which had both a copy constructor that did a shallow copy and a deep copy method that did a deep copy. And we have discovered a new rule of thumb. A given class should either have value semantics or pointer semantics. It probably shouldn't have both. We have also, as we mentioned, removed an untold number of raw pointers. And this was very important because with raw pointers, it's almost impossible to see who's responsible for destroying a particular object. And this is a case where it's not easy to say, here is the pointer which owns this object. This code has many containers, many data structures spread around the code. It's really the only sane way to manage the complexity of the memory management in a project like DoxyPress is with shared pointers.
And many of the declarations and the setup with Doxygen would be a class that contained a class of a class of a class of a pointer. And so we had to narrow that down and reduce it of saying, why do we have pointers that have pointers to pointers? So this is some of the stuff that we trimmed down. It was easier with shared pointers. Now, as a caution of moving from something like 98 to 11, we tried very hard to do this nice and slowly and methodically and gradually, and that didn't work. We actually had to just bite the bullet and stop at one point and say, no, we're moving to shared pointers. When we did that and recompiled, we ended up with 25,000 lines of errors. It was painful. It took about 2 weeks before it compiled again. I was typing, he was reading the errors. It was quite traumatic, but it was the right thing to do, to clean up the code, to get rid of pointers, to move to containers that used values. But 25,000 lines of errors, that was a lot. And we survived after 2 weeks, back to zero. Yes?
For cases where Doxygen was using shallow copy semantics, did you add a move constructor or something like that to take that its place? Or did you use...
That's an excellent question. Yes. In most cases where it was, so the question was, in cases where Doxygen had been using shallow copy semantics, did we add a move constructor to resolve that issue? And the answer typically turns out to be no. In most cases, the shallow copy semantics were actually a mistake. And so there were many places where the classes really had intended to be used in a value semantic fashion, but they weren't actually doing that. And so there are some cases in the current Doxygen code where I believe you can get documentation to be duplicated in places that it should not be because the copies are shallow and should not be. So yeah, most of those cases were unintentional.
But they were also very complicated to work out. We had to start over a few times and say, I think we made a mistake, because there were several classes that were calling the same shallow copy, and trying to grep for that code was not trivial, because again, some of the variable names, I and II, made it difficult. So.
And as a general policy, if the best idea you have to find a particular issue is, let's grep for star,
yeah,
you are not in a good position with the code.
Yes. Another question, or okay, move on?
The other thing that I wanted to mention was that the importance of using a make shared interface. In CopperSpice, we have qMakeShared. It's exactly equivalent to the std make shared function in the standard library. And it is amazing how many exceptional cases we discovered where new was being used in such a way that if an exception had been thrown, there would have been a memory leak. So if you are not already using make shared and you are using shared pointers, you're missing half the equation.
We actually did find many places where there was a delete of a raw pointer, and it crashed the program. And you don't start finding out some of the stuff until you start writing a really good test suite, which our test suite kept growing. Our current test suite for DoxyPress doesn't produce a really good output in Doxygen, but it does in ours. So we have fixed all of those leaks. There are still a few deletes. There's still a few situations and corner cases that we have. We are getting rid of them one by one, but we've gotten rid of the majority of things. One of the other things we had was a for loop issue. We have a small disagreement on our coding style. I'm not a fan of auto. I think that auto, thank you, yes, one person that agrees with me. I think auto, it's not that it's sloppy or lazy, it's just auto, it's like I'm reading his code and I'm like, what data type? I've lost information. So it makes me feel uncomfortable, except Ansel wins on a for loop. Again, the code of I and II and seeing iterators, for loop iterators over these containers, almost had to get glasses adjusted. It was just really hard to read. So if you are using a for loop, I strongly suggest using auto when you're going over a container and using the range-based C++11 syntax. It is much easier to read. Yes, sir?
I have a different opinion. May I share that with you?
Sure.
First, use algorithms, not a loop. Second, with an IDE that will show you the diffuse type. It's not really an issue that auto doesn't spell out what it is, because you hover with your mouse and you will see what is diffuse.
Mm-hmm. It is true that when you do use an editor and you do mouse over it, you will see some information. We actually use an editor that I wrote to test CopperSpice called Diamond. If anybody is from the Windows arena that I am and ever used Crimson, I actually rewrote that product as Diamond to be a lightweight editor, again, to really test CopperSpice. We needed some great ways to test it. I don't have that mouse over feature in our product, but I don't like to have to mouse over just to read what auto does. So I like to be able to read it, and I know it's a wonderful Emacs VI debate as well using auto, which apparently Auto Tools and CMake is also the same VI and Emacs debate. We've got a lot of those. But yes, it's absolutely, I strongly believe in the current for loop range-based syntax, much easier to read, a lot less to type. Absolutely. It is unbelievable how much Doxygen code we got rid of by the time he set up a container and set up his iterators. And he also didn't like to do his declaration of the for loop variable in the for loop. So he had the container and the declaration, and many times he was reusing that information, so he was redeclaring everything. So again, we just got rid of all those declarations, put an auto in there, and Ansel smiled quite a bit because he felt like he taught me something, and he did. So that was quite wonderful. Oh, no. Yes, containers. Yes. Containers, yes.
Another pattern that we discovered time and again in the Doxygen code was misuse of containers, simply using the absolute wrong container for the job. And part of this is not entirely the fault of the original programmers, other than a poor choice of libraries, because the original Qt 1.9 libraries that they based the product on did not have a set at all. And although I'm sure std set was available at the time they were writing this code, for some reason they decided to use a hash map to store a set. And since all of the containers were pointer-based, not value-based, they used a hash map from typically a string or possibly an int to a void pointer. So if you grep the current Doxygen code for typecasts to a void pointer of hex 8 or hex 12, hex 16, it's quite astonishing how many of these you will see. The value is never used. It is simply a placeholder. I think that's approximately the face I made, sir.
Well, and also the problem was reading the code, we spent a good day going, it has to be used somewhere. We're just missing something. And then it's like, let's take it out. Okay, it compiles. Let's run it. Let's see what happens. Again, we don't want to say that Doxygen is a bad product. It was great for when it was developed. It just hasn't been brought forward to C++11, to current day. So I do want to stress that. We're very grateful for all the work that he's done. And we want to see it get better. And that's what we're trying to do here.
So to generalize that rule, what I would say is there are many container classes available, and growing. The standard library is growing every release, which is wonderful. There are also containers available in Boost, there are containers available in CopperSpice, and many other third-party libraries. You would do well to familiarize yourself with the whole menagerie of containers that are available to you in whatever environment you are in, and periodically review your code to make sure you're using them correctly, because it is amazing how many times you will find simply the incorrect container. You might find huge performance problems this way.
One of the other things we ran into is override. There was no overrides in anything that he did, obviously because he wasn't using 11. The way Doxygen is set up, it's a very odd inheritance of the way dictionaries are set up and the way class definitions. There's several base classes set up, and then if you're working in HTML or you're generating output for a different format, everything is inherited and everything is changed. If you're going to RTF, you need a little something different. With no overrides, and here we were changing raw pointers to shared pointers, and we were changing quite a few other things. Well, things stopped compiling. We said, well, let's start adding overrides. At least then we could catch it at compile time, which made it a lot easier. I was sort of a fan of override. I'm now a really big fan of it, because every time we changed a base class, it was, okay, there's another 300 lines of errors we need to fix. So I would always suggest that any current day project you're on, use override so that you know if you're changing your base class or you're changing the inherited class.
Another issue that I'd like to mention that we discovered, although it's not directly relevant to C++11, but it goes along with the times in which we live, is be cognizant of character set encoding issues. There are many reasonable solutions to this problem. The one that we chose is to use UTF-8 internally as much as possible. And I cannot stress this enough. Please understand character set encoding issues. Write code as if you will eventually have to deal with Unicode input and output, because you will.
In line with that, I guess you can tell Doxygen did not, and we had to retrofit. And we had to retrofit and add UTF-8 in. And we didn't count the number of lines of errors on that one, but it was also another week or so of just a headache of fixing everything. Now, the reason why we really ran into that one is because I wanted to change the translation system. In Doxygen, the translation system, the translations themselves are located in H files. And what we wanted to use is standard translations, which is actually built in to CopperSpice. So our CopperSpice library knows exactly where the translations are. There's still extra TS files, which can be converted to some other standards. But the bottom line is now the translation files with DoxyPress are external. They're not in an H file. So it still does take a recompile if you've changed everything, but it's a lot less difficult and a lot less error prone. When we started doing that, UTF-8 hit us really hard. The way everything was set up in Doxygen, there was a lot of problems. And Ansel reads a little bit of German, and I wanted to surprise him. I'd modified a file. I thought it was great. And he says, there's no umlauts and all sorts of German things there. And I wasn't familiar with the full character set, and I thought it looked good to me. But it was completely wrong. Again, the UTF-8 problem, so we had to retrofit.
String handling. It gets brought up time and time again, but we still see mistakes in working with strings. Part of what was amazing about Doxygen is that it actually worked at all. Because the number of places where strings of various classes were auto-converted to const character stars to pass to other functions and then converted back again was amazing. We didn't do any benchmarks on that particular issue, but I suspect we sped up the code considerably just by removing the repetitive conversions from one string class to another. Use a good string class. std string is perfectly good if you know what encoding your strings are in. The QString class in CopperSpice is encoding aware in many ways and can help you out a little bit on that. But please, please, let's all sign a pledge. Don't use const character star anymore.
Yes.
Does QString and CopperSpice use UTF-8 internally?
So the question,
was,
yes.
Does QString and CopperSpice use UTF-8 internally? And the answer is no, it does not. It currently has the same behavior that the Qt QString had, which is to use UTF-16 internally. We're looking at options to improve that because it's not clear that that's the right answer anymore. It probably was when it was first designed.
And we are looking at that quite seriously because this was a little bit painful to do. And we learned a lot about UTF and Unicode and foreign languages. So.
Doesn't the QString by and large use UCS2 and then assume that, make assumptions that lots of things will fit in a 16-bit space?
Qt does make several assumptions. We have actually, in CopperSpice, made some changes to QString, but we haven't decided. There's some design considerations is the problem. It sounds like you understand, is that deciding exactly what should happen with UTF-8, and we are looking at that, at the best way to optimize it.
It is certainly the case that 64,000 characters is enough for everybody is no longer a viable proposition. So. The other issue that we discovered that goes sort of hand in hand with some of the string problems was we didn't realize until this project how important the keyword null pointer is in order for enhancing code readability. And one of the reasons why it's extremely important is because there were so many cases where character pointers were being passed around as strings. You couldn't tell the difference in a function call. You might have a function with 15 parameters or so, which there are many of in the code. And there would be a string of perhaps 5 zeros in the middle of the function call. Some of those are passing null pointers, some of those are passing semantically an empty string to the function. And so one of the most challenging processes that we went through was taking all the zeros, changing it to null pointer, and then seeing all the places where the compiler said, oh, that's not legal anymore. You're passing a string and null pointer isn't a valid string. Oh, I guess that should have been quote, quote, not null pointer.
And we also ran into some problems. We got a little bit of a hurry at one point, and we were doing some checks, and we thought we were checking for null pointers, and we had the not zero backwards because there was no null pointer, there was a zero, and we had our logic backwards. It's a simple mistake to make. It unfortunately breaks the code. So by putting null pointer in it, it made it really obvious. Am I checking for a valid pointer or am I checking for something being null? And again, a zero, very hard to read. Yes. So some of the future plans of where we're going with DoxyPress. We want to see other developers involved. We want to see people using the product. We'd love to be the replacement. One of the things, though, that we do need to do is that we've enhanced the Lex parsing to understand CopperSpice. But Lex isn't the way to go, and we need to change how the parsing works. The other thing is it understands 11, not quite 14, and it's not going to understand 17. Trying to play catch up to keep the Lex parsing. And if you've ever worked with a Lex parser, you would be shaking your head and say, I wish I hadn't. It's somewhat painful hand coding, and especially trying to duplicate efforts that compilers have already done. So what we have done is we've already started working on this piece. We're using libclang for our parsing so we can get rid of the Lex parsing for C++. This way, we can just let the Clang people keep us current for the parsing. We need a lot of information in terms of comments, in terms of the tokens, in terms of everything. We still have to take all the results from libclang and bring everything back together to match the comments. But all of that is already there. It was not trivial because we're in a situation where we needed to compile libclang first on Windows, because Linux and Mac, not so difficult. Windows was, because we needed to be able to compile libclang without using Visual Studio. So we ended up working with some companies that actually helped us using CMake and Ninja so that we could use GCC to eventually compile and get libclang. So it was a very interesting bootstrap process. We do want to support other languages like D and Python and C#. These are some of our plans for the future, is to be able to have DoxyPress, be able to do documentation for other languages. Yes?
Java's not on the list. Is that inconspicuous?
No, we didn't mean to leave Java out. We know that some people use JavaDoc. We absolutely want to support. DoxyPress already does support some languages. I think our desire of what languages to support are people who just raise their hand and say, I need this language or I need this piece changed. We're quite excited to make all these changes now that we have put out the fires, now that we've got the base going. The code's a lot easier to work with. The C++ parser, I think, is our first thing because that's what we need. But other languages we absolutely do want to support. Again, it's really going to be user-driven. And of course, who wants to help us work on it? That's also part of it as well.
And I'll expand on that in terms of there is definitely some support for Java parsing as it exists today. We haven't heavily exercised it as much as we did the other parts of Doxygen, so we don't know as well where it might have deficiencies in parsing. In some sense, Java is a simpler language to parse than modern current C++ 14 or 17 will be. So I would not be surprised if the Java support was significantly better than what we encountered in the C++ arena.
We also have several different formats. We've maintained all the output formats that you would find in Doxygen, I mean the RTF and stuff. We've had a few people asking, well, maybe you could do a JSON output. And it's like, okay, we hadn't seen a need for that, but we're going to put that on the list. Somebody wants to use a JSON format or there were some comments of being able to output stuff just directly at the same time you're uploading to GitHub, get me the documentation, so everything is tied together. So there's a lot of different scenarios we've already been hearing of people making requests. Currently, if your documentation is embedded, which he likes, I don't like. My documentation is separate. I don't like it clogging up my code. We've also heard some requests of, I want my comments over here. So we're changing how things can be generated in terms of the code of the documentation. There's currently some changes we've also made to how everything is formatted, how it understands the CSS, and how the output actually looks. We've already made several changes to some of the format files.
One of the other areas that we definitely want to tackle, and we have already improved it significantly, but there is much more to be done, is to redesign some of the internal data structures for increased efficiency. And the reason for this is that the larger a project is, the more urgently it needs good documentation. And so most of our most interesting possible use cases involve very large code bases. And generating documentation is, as of yet, still a slow process. We are faster than Doxygen for many cases. However, it still takes a significant amount of time to generate the documentation for our CopperSpice libraries, and that's an unneeded drag on developer productivity that we would like to remove as much as possible.
In DoxyPress, if you're using the DoxyPressApp, which you can then just click a button and generate documentation, the output that it showed on the screen was a little bit awkward. We have cleaned that up, but as I watch it, and each time we make an improvement into the product, I see less information that's going wrong, and I see more information of what's being documented. But there were places in there that things are being documented multiple times. One of the problems that we've actually seen, and again, this is just the internals, is he's running through the documentation twice and picking up information each time. You should only have to run through it once and then get all the information out to all the containers. So again, there's some cleanup, but this had to be deferred until we had the API for CopperSpice that it could actually generate. And now we know exactly what it's supposed to look like. So now it's a lot easier to take an existing form of our documentation and to say, okay, now let's clean up these internal classes so that there's not as many containers that it's using, and we can figure out a better way to assimilate all the information that we need with the code and the documentation. Just to let everybody know, like I said, we're the founders of CopperSpice. We're going to be doing a talk on CopperSpice at 2 o'clock tomorrow afternoon, and we're going to go through quite a bit of information. We're also doing a lightning talk on Wednesday evening talking about how we implemented reflection using straight C++11. We have some really interesting code to show on that and how to do a counter at compile time using some template magic. If you're interested in taking a look ahead of time in terms of CopperSpice, we do have Kitchen Sink. Kitchen Sink is a demo that contains 30 demo programs inside of it. So if you're not familiar what CopperSpice can do, or all the different types of things we can incorporate in terms of a GUI library, Kitchen Sink, binaries, and source code are available. Like I mentioned before, Diamond is a lightweight editor, does work on all platforms. I just found it really nice, and we keep adding more features to it. And then there is DoxyPress and DoxyPressApp. In terms of GitHub, currently CopperSpice is on GitHub. DoxyPress and DoxyPressApp will be added next week onto GitHub, but source and so binaries and source are all available on our website from the links from our copperspice.org, .net, .info. I think we bought one of everything. So, questions about DoxyPress that we can answer for you? That's really the information that we had. We hope this was helpful and informative. Yes?
So I think the quality metric is pretty obvious, but do you have any idea what kind of performance, like memory or time improvements you've seen since the version 4 dropped?
Yes. The question has to do with performance changes going from Doxygen to DoxyPress. Well, one of the things I can absolutely say is the API for CopperSpice, what it produced was completely useless. It didn't understand the macros. It didn't understand the C++. The time frame, though, did go from probably about 15 minutes down to 5. And it's just a rough guide. We understand that documentation isn't something you always generate. So if it's a couple minutes, that's really not a big issue. We did see improvement go way down. And more is documented, actually. Like we were talking about the autobrief. We had autobrief stuff just dropped on the floor. One of the things we've also added to DoxyPress is some checking. So for instance, if you have a declaration in your documentation and in your code, we're actually now reporting errors that say your types don't agree. I mean, you've declared one thing over here and this isn't declared the same. Obviously, you can ignore that if that's what you wanted, but it is nice to know that your documentation does not agree with your actual H file and your declarations. So, yes?
I have a question about testing. So you basically took an existing large code base and started rewriting it. Have you spent any time writing unit tests for components of this large code base? And if so, how did you approach separating the modules which not necessarily which were or weren't prepared for unit testing beforehand? Just generally, do you have any experience with
So
that area?
your question was about how did we integrate unit testing with a large existing code base? And the answer is that our strategy has been more input and output testing than individual unit testing, because one of the nice things about the documentation generation program in concept is that if you give it the same input, you should always get an exact expected output. So our test suite is in the form of just a large set of various inputs and verifying that we get the correct answers out.
And that did work in the sense that, like we mentioned, div didn't work. So our first unit test was, hey, let's take some code and put an opening and a closing div. The problem with div had been that it open, closed, open, closed, open, closed way too many times. And now it doesn't. So our unit test is not individual ones. It is one set of documentation that we generate. And actually, if you look at it, and that is available, our unit test is part of the binary and the source. You can find that with DoxyPress. It's all there. So it just grew as terms of, oh, autobrief broke. Well, let's add autobrief. And each page actually says what it's testing. So we figured that if that runs and it produces a good output, then it passed. Yes?
How about the HTML compliance? Is that improved?
Yes, HTML compliance is absolutely improved. Like I said, the DLs, the DTs, we had problems. And when I generate tables, I like blank lines every so often so that I can read everything. So everything is compliant in terms of that. And if there are still issues, please let us know. We want this to be absolutely compliant and absolutely HTML5, that it's absolutely working. Yes?
Do you have a view on the compatibility with existing Doxygen tags or the future with extending the Doxygen syntax some way?
So the question was about whether we support all the existing Doxygen tags and how we're going to extend them in the future. And the answer would be, yes, we do plan on extending them. And we do certainly want to maintain compatibility with existing Doxygen tags. There's no reason why that shouldn't be the case.
We currently do support everything that they do have. Our documentation of DoxyPress obviously was generated. We completely rewrote the documentation starting with his documentation. We did rewrite it in DoxyPress, of course, but everything is there. So we haven't removed anything. Yes, in the back.
Are you envisioning having CppCon as a dependency for DoxyPress going in the future forever, or is that something potentially that could be removed?
So the question was, do we envision having CppCon as a dependency for DoxyPress indefinitely? There are currently no plans to remove it. There is no reason in theory why you couldn't rewrite the entire thing in standard C++, with the exception of the DoxyPressApp GUI interface, which still needs access to a GUI library. However, it would be a monumental task, significantly larger than the one that we've already undertaken to get to this point, because of the API mismatches between even the old Qt container classes and current STL state-of-the-art.
The very nice thing, though, that's happened because of this is in the process of developing this, we were looking at it, we were going, we needed case-insensitive sorts and to actually do some of the stuff we wanted to do in DoxyPress. And we looked at each other and said, wait a minute, we have CppCon. Let's just fix CppCon. So we actually added the third parameter to QMap so that we can specify a template to do sorting. And it was like, wow, it's good to be able to do this. So I will say that CppCon has changed and evolved because of things we needed in DoxyPress. So we really haven't seen a need to separate the two. Most people, we feel, will just use DoxyPress as is. And the fact that it was using Qt 1.9 and now it's using CppCon won't actually be an issue for most people. Yes, sir.
So I have two questions. The first one is, what would you say, or to what extent did you change the architecture of the original project after you forked?
So the question was, to what extent did we change the architecture of the original project? And the overall architecture of the project has not dramatically changed at this point. There's a large number of improvements that have been made in individual pieces, but somebody who is a current Doxygen developer would probably at least recognize the structure of the program.
Well, that's what I was beginning to think, that this was an incremental, repeatedly incremental change, which comes to my second point. If you listen to Rustrup's keynote today, he talked about the use and potential overuse of shared pointer, but given your situation, the first thing you needed was safety as you went in and excavated. And then after having done that, if performance is still an issue, another pass might be to go see, well, I can use raw pointers here and call them dumb pointers because there's a dumb pointer type. And then there's the use of some sort of owning a smart pointer for those things that need to come back as pointers. But as Strustrup said, having RAII be the driving force without the sharing, because sometimes you don't need the sharing. In fact, perhaps often you don't need the sharing, and a combination of dumb pointers and RAII smart pointers might be faster. That was just my thought. Is part of the reason why you chose to use smart pointers pervasively because safety?
So
the question
had to
is
do with is the reason why we chose smart pointers rather than some sort of owning and non-owning raw pointer functionality. Does it have to do with safety? And the answer is yes, to some extent.
Yes.
However, the way that the data structures in Doxygen and DoxyPress, because the architecture didn't markedly change, as my previous answer indicated, the structure of the program does not lend itself to being able to define an owner for a given piece of data. In some code, this is easy. This is simple. In the case of this code, there is a large corpus of data that's collected during parsing your program and stuffed into this gigantic graph. And in theory, it would certainly be possible to tease out an owner for each piece of data, but it would be extremely challenging and very difficult to maintain going down the road. So as we look at performance issues in the code, it's more likely that we will find the gains in other places in terms of algorithmic improvements and data structure improvements than going back to raw pointers. It certainly would be possible, but I'm not sure it would be an improvement.
One last follow-up.
Yes.
If you were doing this from scratch, and I realize that's a big project,
yes.
would you have designed it differently? And if so, how?
Yes, so the question is, would we have designed this product differently if we'd done it from scratch? And the place where we would have is exactly what we are going to change, and that is the overall architecture. Because like we've talked about, there's this dictionary, and then there's all these sub-places. So various pieces of code goes over here, and comments go over here, and the way it's all spread out, we actually have a flowchart right now that's a little bit daunting, and we had to have the flowchart because of some of the naming, and it's like the class defs and the member defs, and all these definitions flowed everywhere and inherit from each other. It's not that it's wrong, it's just that doing it again, we would have laid it out a little different. And I think that is our approach that we'd like to do, is clean it up so there's not so many levels, so that you don't have to parse everything twice. And I would like to add that after hearing Strustrup's comments this morning, we were both going, should we put some raw pointers back in? And we both said, no. This product doesn't call for that. But again, the optimization, even though code, so it takes 3 minutes or 5 minutes to generate. No, I want it in 1. I'm right there with everybody else. I want it done quickly. So and our Copper Spice API, that's my test, because 15 minutes was just I had better things to do. It was taking way too long. Yes, sir.
I'm working on a codebase where Doxygen takes several hours to generate documentation, and we were wondering whether it was possible to have some multi-threaded way to get things going, or even better, compile time, just generating some helper files, which then afterwards get grouped into the documentation.
So the question was about a large code base that's taking several hours to build documentation for, and whether there's a multi-threaded or possibly segmented way that we could do documentation. Adding multi-threading to the current code base would be a significant challenge. Having added shared pointers, it would actually be a little more possible than it previously would have been. But it certainly would not be a weekend project. So in terms of speed improvements, like I said, it's not so much in terms of multi-threading. The primary work that's done is actually in parsing the code, and that you might be able to do in a multi-threaded fashion. But that's not currently on our roadmap. I think that we can get a lot more performance improvement by cleaning up the current code and getting it to a better architecture. And then at that point, we'd also be in a better situation to add multi-threading to the code base.
Because again, it really does parse twice. And we do have to pull in all the comments and read through all the code and take the H files, and everything has to be put together. But having to read through some of this stuff and go, okay, now we've read the comments for this, and now we've read it for this. There are places where it goes through 3 times. And it's a little bit strange. And again, I think it was a great beginning of a great product, but that was 15 years ago. It just needs a piece of a rewrite. We couldn't get there until we did this. And the fires are out, and we've got the basic things working, so now it's time to make it work right. Oh, yes. Oh, yes. Clang isn't actually, the question is about Clang. In Doxygen, he's not actually really using Clang.
Yeah, but in Clang itself,
yes.
They have warnings on documentation,
yes.
which is related to Doxygen. And there they also do parsing twice.
Yes.
For the documentation. I don't think that's a real issue then.
The comment was about that Clang, in part of its warning generation for bad Doxygen style comments, parses the code twice. And that's a slightly different issue. In terms of parsing one given piece of code twice, that's not that expensive. But when you're walking the entire global data structure of the whole code base twice, you're adding at least 50% to the cost of the project.
Yes.
First of all, thank you for taking the time to refactor Doxygen, because its problems have been a thorn in all of our sides for many, many years. I'm not sure if you're aware of the history of the attempts to come up with a documentation tool that was better. Dave Abrams had a lot of push to try and push in that direction for some time. Stefan Seyfield, who's had a boost, also tried to do his own documentation generated for C++. There's a litany of projects that started and got quite far in some cases, but the trouble was that Doxygen kind of somehow or other got the majority head start, and it just became the leader, and everyone just defaulted to it.
Yes.
And that has led then to outputting Doxygen XML, which a whole lot of other tools began to start consuming, to the boost documentation generation tool, which can only accept Doxygen XML in its very strange output form.
Yes.
It's really weird, and you have to keep manipulating it, trying to get it into something useful. And it's sort of, it's kind of turned into this ball that just rolls down a hill under its own steam. And it's kind of, everyone I think would really love if someone went off and completely rewrote from scratch, actually completely the same inputs, but code would produce a bit better in a format of XML output, but something that ran faster. But as you say, it's a huge project, and all of these litany of projects up until now have failed, often by really talented people, or members
yes.
of the community. So I just wanted to thank you personally for taking the initiative to go and refactor Doxygen, which is, I've had many run-ins over the past as being trying to modify the source code myself, and I totally give my heart out to you on how hard it is. And you've done an amazing thing. So thank you very much.
Thank you. Thank you. Just for the microphone and the camera, we were just thanked for our lovely work, and we absolutely appreciate that, because there has been a lot of time in the last year we're wondering, will this matter to the community? So our time is over for right now. Thank you so much. Please take a look, please contribute, be part of this with us. We're very easy to work with and very friendly, and we look forward to comments as they come in. Thank you so much.